and my co-author Ramana and I raised the aircraft analogy advisedly. Uh, the cost, an aircraft may cost 100, $200 million, depending on the aircraft. A small modular reactor would be in the hundreds of millions, 60 megawatts, $5,000, uh, $5 million megawatt. You're talking a few hundred, couple of hundred, 300, $400 million. So it's a similar scale. And so you're talking about mass manufacturing and component supply on a similar scale. You're talking hundreds of or thousands, probably thousands of reactors per year to be manufactured to be able to set up an economical supply chain using the aircraft analogy. You're not talking small widgets or plastic bottles or something like
Right.
that. You're talking a big device that takes time and that's worth hundreds of millions. So, and then the whole, the say the Boeing or Airbus supply chains, which are the close analogy, their supply chains are far flung and worldwide. They're huge, huge businesses. And to set up a supply chain like that, you have to have a pretty hefty order book. And to have a pretty hefty order book, you have to show that it's cheap or will cost as advertised. Now, the proponents themselves recognize that unless you have a supply chain and mass manufacturing, you can't make it about the same as existing reactors. You have to make up for those economies of scale. And no one has proposed, other than massive government procurement of reactors in the hundreds or the thousands, how these supply chains would be set up. So basically, whether it's explicit or not, what is being proposed is thousands of reactors should be built at higher cost than existing reactors in order to bring the cost of small modular reactors down to the cost of existing reactors. That's the definition of success. And as we said in our article, if you succeed, you've still failed because existing reactors are far too expensive and unaffordable. So now you've had a fantastic success in mass manufacturing and an economic failure